All right. So I figured I'd go live 1 minute before. 1 minute before, everyone. So, yeah, just trying to get things started. Trying to get everything going here. So, yeah, today is going to be the talk about why TypeScript. Um, Truthfully, yeah, why TypeScript? Why go TypeScript? Why was TypeScript created? Um, why do people use it? Why did it become so popular? Um, Thanks there, Sean. I believe that is, yeah, for showing up. Um, so why did we do this? Why is TypeScript so important? Why did it become the language it did? I'm telling you right now, I've already posted this before. It's not because I'm a Microsoft shill. I really, not a huge fan of the company, but I will say one thing. I think TypeScript is one of the things, that and C# are probably about the two things I really have to say I like from Microsoft. Um, Both of them, by the way, were created by the same person. The person who created C# is also the same person who's the main creator of TypeScript. So that's probably why I love them both. If I love C#, more than likely I'm going to love TypeScript. TypeScript really, people call it a language. Is it a language? Yeah. It has a compiler, so I guess that does make it a language. Um, it adds features to JavaScript that weren't that aren't there by default, even with the new class features that have come into the JavaScript language. Uh, Variables, parameters, all of those things are not typed. There is no typing support for JavaScript. And while I understand why that's done, especially when you're coming upon data type applications, I really think TypeScript is one of those things that's almost invaluable. Really, I mean, it really is. It's almost invaluable. Um, I've got some code examples here, but we're going to start off. We're going to start off by going back to pre-TypeScript. So that's where the talk's going to begin. I think I like going back a little bit in history. It kind of helps people. It helps people to understand. I got a question here that person asks if is it similar to Sass or CSS? So how Sass is to CSS? Yeah, kind of. In a sort, it almost is like a preprocessor, like kind of like the way Sass or SCSS is. And I was actually going to bring that up just a little bit later, because like I said, the only thing that I really think makes it a language is the fact it technically has a compiler. There's the TSC command, which is the TypeScript compiler. So, it, but everything that TypeScript does, it writes back into JavaScript, which is a lot like Sass, a lot like SCSS. So, very good question there, and that's very true. So, yeah, it kind of is it a language? Is it a preprocessor? Who knows, really, right? Um, Regardless, I do think what it does add is very helpful. So, if anyone saw my last stream, I explained the difference between Java and JavaScript. So the question was, what is, and so I went into the history of JavaScript, and all that kind of stuff. And the basis, I'll do a very short recap of that. The basics came down to JavaScript was created because when the web first came out and they started getting static HTML, they wanted to provide interactivity to static HTML sites. I made the example. I don't know if I made the example then, or if I've made the examples in posts on X, on my X account, about where we used to do images, image menus and things like that with the little over, or with the rollovers, or the mouse over things with JavaScript. That's what we used to do, because before we had things like, I mean, CSS was around back then, but it was very, very rudimentary. And so there were no on hovers, there were no hover events and all the other events that CSS now sort of handles and interacts directly with the browser. So back then, that's a lot of the interactivity was done in JavaScript, and that's why JavaScript was the way it was. That's why there wasn't really much concern for types and typing. Um, I in my guess, without actually digging in and speaking to the people directly, my guess is they probably wanted to make something as quick as possible. They were originally going to use another language that was already created, but which was similar in its dynamic nature. I'd have to look it up to remember exactly what language they were thinking of, but it was a language I think that was in use out in Unix, the Unix Linux world at the time. And so when they created something, I think they wanted to create something that was similar to that language, and that's why they made the choices they did with JavaScript. So the idea initially was just to make it as simple as possible, so you could provide interactivity. So when you hover over a section, you could do something, with the HTML. You could actually modify the HTML, add things, which is you can still do to this day with JavaScript. It's just we have better tools now, so we don't really use that. But that's really where the beginnings of JavaScript started, and so that was the whole point. So really, at the time, the concept of loading data through JavaScript really wasn't there. Now, there were scripting languages and things of that nature. There were databases and there were data-driven applications, but most of those were scripting languages like I say it this way: classic ASP. That's before ASP.NET. PHP, that was around back then. That actually came out right when I was in the middle of college. That came out in the late 90s because I remember it coming out when I was towards the end of my college years there. And I remember that was actually I had to do a senior project, and we did it in PHP. So the ideas of these scripting languages that have scripts that have tags in there and allow you to take data that comes in and then produce HTML. The final result was HTML, and to the end user, if they were to inspect your source at that time, you would just see HTML, and it would look like just this HTML. But behind the scenes, in the script, you were doing all of this work, all of this run through work, and all of that. And so JavaScript still had a very small part because mostly, I remember when I first started out, mostly JavaScript was used for field validation in forms. So if you were going to fill in a form, you were going to submit it, you didn't want to take you don't want to take the hit of going back to the server and having the server tell you it was wrong and then coming back, especially if you could just do it in JavaScript right there. So that was the whole point. JavaScript basically would sit there and say, okay, well, these are required fields, so these have to be filled in. You could go a little bit further and you could say, okay, well, this field requires numbers. So if they entered something that wasn't numbers, you'd specifically tell them, hey, this needs to be numbers. If you were a really smart JavaScript developer, you wouldn't even let the field type the numbers in. So if they type something besides a number, it would just not let them type it in. Of course, that does have some side effects. I think I did that once, and someone told me, no, don't do that, because then the user's going to think something's wrong, which is true. They're sitting there typing and nothing's coming. So, I mean, you could kind of tell them, hey, only numbers, whatever. But that was the idea. JavaScript was really, kind of for the most basic stuff in that kind of way. Then JSON came about. And no, not the name Jason, JSON. JavaScript object notation. And XML HTTP. So in IE5.5, the XML HTTP plugin, I don't know what you want to call it, to Internet Explorer 5.5 came out. I know this because I was working at a company when IE5.5 came out, and I remember one of the senior devs there did a really, really cool feature that I was like, how can you do this? And he our system needed to upload large files, like multiple megabytes, many megabytes of files, and they wanted an actual feedback to the user how far along the process it was. And so I saw them do this once, and I actually was running a test, and I would watch it actually update, and I said to the guy, how are you doing this? I said, are you actually posting back to the server and it's just so fast I'm not seeing it? He goes, no, it's XML HTTP. I said, what is that? That is what eventually became known as AJAX, and now asynchronous JavaScript and XML is what AJAX stands for. And eventually you started seeing that come up in a lot of JavaScript, and that's where the whole JavaScript thing kind of started taking off. So once we had the ability to communicate through JSON, and we had the ability to actually from the actual web page from within JavaScript, sorry there, to send out a request to an actual server endpoint and get back data, the whole thing changed. I mean, JavaScript went from a simple scripting language to starting to become something really serious. Let's see here. As a dev who's only used TypeScript once, do you think it's worth it for new WordPress projects to try out TypeScript rather than block theme and Sass? Uh, hmm. I've only dealt in WordPress once, and it's mostly PHP. But the front end could be anything. I guess it could, couldn't it? You could write, the front end and then have PHP somewhere there. It comes down. That question to me would be: it comes down to how much work it's going to be to get TypeScript implemented. If let me try to get back to that here after I go through the history. So I'll try to keep your question in mind here when I get back to actually dealing with TypeScript. Okay, so basically, yeah. So that's where we were. So now we've got data coming into JavaScript, and trust me, I was there. I was there when those early applications. I was there with Backbone and Knockout when we first started doing a lot of these, really interesting and really cool projects. But my gosh, these things, I mean, errors would just come out of nowhere because, you didn't expect something to change. You thought that a piece of data was this way, but it was really this way. You thought that only certain things were going to call this method. I hear love and hate about it. Yeah, there's a lot of people who are hate. Actually, it's funny. I will address this one, Tony. It's funny because most of the people I posted to as on the lead up to this on X were saying that they love TypeScript, but and they were wondering who has all this hate. But I've posted a lot of things about TypeScript, and I agree with you. I've gotten the hate from it too. And like I said, I'm not saying TypeScript is a must for every single application, but for data applications, I really don't see the reason why not to use it. And that's where I'm headed with this right here. Is when it comes down to normal data applications inside of JavaScript, I really don't see a reason not to use it. So yeah, that's where things really started getting difficult, because you would think, okay, well, this function, this method over here, this object should only take this type of data. And so, hey, Jason. So yeah, that's where TypeScript really, in my opinion, comes in and helps out a lot. Now, I think this is where a lot of people kind of get the hate for TypeScript right here. But you have to think about it this way. Okay, so you have this function here, or this method inside of this JavaScript object that you expect that it'll only accept a certain type of data. So you've got this object that's passed in, and you just assume that it's going to be a particular type of data, and you just start working on it. Well, that's great. But let's say now this object is used in 10, 15 different places throughout your entire system, and each one is making calls to it and all kinds of stuff. It's going to be very difficult to go through all 15 and try to figure out when you're getting an error because you sent the wrong data type to that in one particular place. You've got to go and find out where it is. Now, granted, yes, sometimes you do get a nice stack trace. Sometimes you didn't, especially in earlier JavaScript. Sometimes you just got an error in the console, and good luck. Let's go find those 15 places. Let's go through those 15 places and try to see what the data type is. So console log everything, every single place that it could be in, and all of that kind of stuff. And it just became an absolute nightmare. It really did. And so, yeah, it was very difficult to find. So what you ended up having to do inside of this function, if you wanted to make sure that your object was of the right type, is you literally had to write typing code. So you had to write, JavaScript code. Let's just call it object. If type of object is object. So is it an object? Yes, it's an object. Great. So now at least know that you've got an object inside of there. If object dot field one exists. If object.field1 is all you would write, because in JavaScript, that's enough to know that if it's undefined, then it's false. If it's defined, it's true. And type of object.field1 is string, let's say. So, and imagine writing that for every single function that needed to validate every single object that gets passed into every single place. It was a nightmare. We had, I mean, I would usually wrap them inside of a function and then call them inside of there, but it was a nightmare because every single one of these, if you had the possibility of something coming through, you wanted to catch it so that you could actually tell the user who was creating the application you passed the wrong data, so they would get an error back before that thing got deployed, and then the user or the developer would end up catching it. But to write that stuff was an absolute nightmare. And this is where I think people don't understand. People who are really against TypeScript don't understand. Yes, in TypeScript, you need to create your types, you need to create your interfaces and define the different fields in there. But it's the same thing you would do if you were in JavaScript alone. And honestly, it's a lot, in my opinion, it's a lot simpler. Plus, there's an advantage you get from this. You get the advantage that now when someone else goes to call that function or goes to call that method, they will actually get the type that they're supposed to. And if they pass the wrong type, it will actually throw them an error. That's and right then and there. And you don't have to write this code. All you have to do is you have to write your interface one time, and you have to use that interface in your actual parameter as the type of your parameter. I'll be showing some code examples here very soon. This is where I think TypeScript really comes into play. This is where the love and hate is. I believe a lot of the hate that comes for TypeScript is the fact that you have to write all of these types. You have to sit there and you have to write out these types and you have to do stuff. But trust me, it's 10 times easier to write that type than it is to write that checking code over and over and over again. And I had to do that in an application because we had a problem where we had, huge amounts of places that were called, to very specific functions. And we would get these errors all the time. And so I had to sit there and each time we did that, I had to write this over and over and over again. And it just became an absolute nightmare of maintenance, because then what happens when the data changes? When the data changes, you go back and do that. Now, yes, you have to do the same in TypeScript. You have to go back and you have to change your object. But to me, modifying a simple little object over here is a lot simpler than sitting there and trying to rethink going through this big if logic structure and trying to figure out where it needs to be and what needs to come out. Instead, you're just looking at this. You're looking at this interface that has your definition inside of it, and that's it. Like I said, we'll be showing that here very shortly. Is there anything else I need to do before I go to the code? Because TypeScript is a lot more. What I just gave there is a very simple example of what TypeScript of how TypeScript is used, but it has some pretty advanced features, and I'm going to show some of those pretty advanced features today. I promised I would go into generics today to someone else, and I will be doing that. Let's see here. Coming from learning C and C++ in college, when I learned JavaScript, I couldn't come to like it. Yeah, it's especially when you come from a typed language to a dynamic language like JavaScript, it can be jarring at first. I will admit that. Let's see here. Comfortable JavaScript, except where asynchronous nature comes in. Do you think it's better to transition to TypeScript at this stage? Because sometimes I write the data type before declaring variables and remove it after giving an error. I do think TypeScript, like I said, anywhere where TypeScript where you're going to be using data, I think TypeScript is invaluable, because exactly right. That's what I did in the company I work for right now. That's what I did. Is we defined a lot of our because we have a lot of interfaces to actual APIs that are calling data and returning data back. So we wrote all our types in there so that when we're actually making these calls to this API, we get typed data back. We actually get our actual typed data back, and we know what's in there, and we know what properties are there, what objects are there, and all that. And it makes it a lot easier to use in our applications because now we have all of our data coming from the API is actually typed. Yes, once again, you make out this whole issue with, I have to do the extra work, but it's really not that much extra work compared to what you'd already be doing anyways, especially when you run into all the problems with just having no types whatsoever. And I've recently come into someone else's project who we had another team do a project for us at my full-time job, and they didn't use TypeScript, and it is a nightmare. It is an absolute nightmare. It's all JavaScript, and it's all I started putting TypeScript in there and started trying to make it better. It is an absolute nightmare. Am I familiar with other languages? Yes, I am familiar with other languages. Um, I started in college. I started C, C++. Well, yeah, I did do a little C++. Java was my big language in uh, in college. JavaScript, of course, PHP. I told you that came out at the time. Um, let's see here. Then uh, VB script, although I won't admit that on my resume. I don't put it on my resume because I really absolutely hated VB script. Um, let's see here. What else? I know there's a couple more in there. If you count HTML and CSS, but those are half languages. Let's see here. Oh, Visual Basic, good one, good one. Yes, yes, yes. Visual Basic. That's one of the ones I absolutely hated, but I used a lot. Russian, good one, good one. No, duh. There we go. There's my Russian for you. Anyways, yeah, there's a couple more in there, and right now you're putting me on the spot, and I can't remember them. Oh, C sharp. Why didn't I say C sharp? Yes, of course, C sharp. You made me stutter. Yeah, you did. Yeah, yeah. Oh, QBasic. QBasic was one of them. Yeah, yeah. HTML, like I said, that one was kind of like, is it a language? Is it not? It's kind of halfway. Anyways, yeah. There's a great number of languages I've done. I've done the best language. So I've done a lot of those different languages, and so I'm always willing to jump into places and do things. I think it's a good time now to transition over to the actual code because this looks like it's actually going to run longer than 30 minutes, and I don't want to take too long. But it's been really cool. I actually XML. XML, if you count XML, XML's in there as well. I've done a lot of XML. Definitely DTDs and all of that kind of stuff, which, by the way, if anyone's wondering, JSON has the same thing. JSON has its own type definition language as well that you can validate JSON data in. There's a framework out there. It's not really used anymore because there's a lot of things that don't there's a lot of advancements in some of the newer frameworks that don't really apply anymore. But there was something called schema form. JSON schema form was a really good library I was using about, oh boy, that was just almost 10 years ago now. But it's good. It's good. Let me see. We're gonna do a screen share now. So, oh yeah. Let's see. I could do entire screen, but it's gonna do that whole wave thing. But then I can jump between things a lot easier. I might go ahead and just do share and then unshare. I think that might be better. Okay, so we'll start with Bsoft components. This is the library that I actually use. Good. All right, looks like we're streaming right. All right, this is the library that I actually am working on. It's an open source library that I work on the weekends right now with a team. There's a team of people that are trying to contribute to this and all this stuff. Right now, we're in the middle of what's known as a headless component conversion. Basically, taking all of our components and converting to headless components. I'm not going to go through the whole definition of headless components. I've actually talked about this before. If anyone wants it, I can find the old video and post it back up on X again, or post it back to it. You can probably find it on YouTube if you want to look at YouTube. I think YouTube saves everything I've done. I don't think it deletes anything. So you can go back through there and look at the headless component conversion talk and all that, and that'll explain headless components. Anyways, what I'm trying to get to here is the props. So here's where we'll start. We'll start with this. This is the most basic of TypeScript. This is the basic definition of interfaces that I was talking about. We'll go through this because this is basically the props here. So that's the props here. And in our case, we pull out some of them and utilize some of them in the way you see there. Interfaces in TypeScript can be inherited. That's what the extends keyword is. Form input control is my own item that basically lists out all the potential properties of form components. Basically ID, label, name, value. Is it read only? Is there a placeholder if it's like a text box or a drop down or something that has the select, you can leave like a little piece of text in there. On focus, blur, on input, and on change. On input is for like text properties. I have a, what is it called here? Continue. Hang on, I'll find it here. Of course I won't. Oh, there it is. It's an inputs and it's content editable. So content editable inputs fire the on input instead of on change. And then class name. So that's something that you'll see in most React components, is the ability to pass CSS into a component and override certain pieces of it. So almost every one of them require or allows a class name. And then this one is form input control data. So this is specifically for data loaded components, which I don't think any of ours are yet. I do have a data loading component, but not a data loaded component. The first data loaded component after we do this headless conversion is going to be a drop down component, and it will use this. But the data, potentially the data that's coming in, actually it probably will be in my case, the data that's coming in. JSON data is just that. It's an array of JSON data, of JSON item, and JSON item is record string unknown, which is a type. Record is a type inside of TypeScript. And I'm not sure if you can see this, since my screen might be a little bit small, but there's actually a little thing down here that shows you exactly what the type is, which it basically just allows you to put, it's key value pairs is what it is. The record string unknown is basically what JSON is, key value pairs, name, potential value within that property. And so basically, yeah, the text and value field would then, in the case of a dropdown, the value field is what gets set to the value of the component when the actual text is selected. The text is what you see. So that's why value and text field. And then data, of course, because then that's where the data is coming from. So you would loop through the array of data. Text, value goes into the value property. Text is the display property. So pretty basic stuff there overall. But yeah, then I've added a couple more for the headless checkbox components. Checked, partial checked. Our checkbox is allowed to be partially checked. Only programmatically. It cannot be done by the user. The user can't sit there and check. It doesn't have 3 states. It only within the when the user uses it, it only has 2 states. So yeah, checked and partial checked, and that's pretty much it. Label styles for the actual label itself, and then every one of our headless components has a child render prop, child render prop. So basically, you can pass it in, and it basically renders. I will show you how that works really quickly. If we go down here, here is headless checkbox, the guy we were just looking at, and this is the child render prop. So the only thing we really care about is the partial flag. If it's partial, then it goes partial. If not, then it basically determines whether or not it's checked. So pretty basic. This is why headless components are so nice, because basically you can do things that are very simple. As you can see, there's not really a lot of logic in here. Most of the logic is for styling purposes. So a lot of CSS in here. This is a CSS property, in case you're wondering. And so yeah, passes CSS to it and all that kind of stuff. So that's where the headless component, that's why. What we're looking at here, what I'm trying to do here, because we're going to jump over to another library called bsoft common, which some of these things are within, and that's when we'll show some of the real guts of TypeScript. Use property change. The reason I created this hook, this is for those of you that have never seen React before, this is what's referred to as a hook. Hooks can only be called in one of 2 places. At the top level of the component, here's the component. So it's called at the top level. It's not embedded in anything else. It couldn't be called inside of here, for example. It couldn't be called inside of a use effect. You can't put them inside of a use effect, I'm pretty sure. Or the only other place is inside of another hook. But still, it still has the rule of hooks in there. If you put it inside of another hook, it has to be at the top level of that hook. So that's the only place that hooks can be done. I will actually be showing use property change. At least I'm pretty sure I've got it already loaded up in bsoft common and show you what it does. What it does basically is it checks each time the component is rendered and is called. It checks the check property to see if it is changed. It then gets back a, let's see if it'll show the actual. No, of course it won't. No, it won't show the property return type. Anyways, hang on here. I might be able to do that. And then might be able to do that. There we go. Yeah. So basically, we already know what the current value is because we have it in the property. It shows whether or not it's changed as a Boolean, and then it has the previous value. This is where generics really come into play really well. I've mentioned this to people before about generics and how generics are really, I think, one of the cooler features of TypeScript, and one of the things that makes it really usable. So if you look where it's used here, the property that's passed in is typed of T. That type is then passed to the property change return type. So what this is referred to here is called type inference. So we don't know when this is called, when this is created. We don't know what the actual type of the property is. But when we go back here, when this gets passed in, this is of a type Boolean. So now the actual previous type, the T there, is now a Boolean because this item was passed in here. But we don't have to manually call, because you could just say this. You could go like this and then say, if it'll actually show up here, there it is, and then say Boolean. You could do that and that would work. It would do the same thing. But there's absolutely no reason to have to do that, because we've got the check, because the check property has a type already, and it gives us that type in there. As you can see, Boolean is the type. So that's kind of the basics of TypeScript here. As you can see, we've got headless checkbox props, which is this here. This is our final props that we're passing on to the actual headless component. I'm not going to go through all the headless component stuff. I've got a separate, like I said, if you guys want, you can go through my previous things to see that. I don't want to spend too much time covering that. Let's see here. In case anyone is actually messaging, I'm not seeing it because I am on the code here, so I will try to look when I get back. All right, that's probably good. We are going to switch out here. That would be good, Jason. We ought to take a look at that. I'm going to go ahead and, yes, replace the screen sharing. Here we go. We're going to change to a new screen. This will be the BSoft Common. This is the one that has the guts I was speaking of here. So, oops, let's see. There we are. Okay. Use property change. This is the one I was looking at right here that I was showing you. Here's the property change interface that we were looking at before. Here's this, but it didn't show the guts. And this is going to be a little bit of React, but it's definitely TypeScripty React. So it's React with TypeScript. So we'll get a little bit of a mixture here in the whole stream. Pretty basic. Refs. If none of you know about what refs do inside of React, refs. When you change the value of a ref, it does not cause a render within a component. State causes component re-renders. Refs don't, and that's why you use it, because then you can store things, you can change the value of things, and if those items aren't important enough to cause another render, then you should use ref. Basically, so yeah, the first time it's called through, the ref is undefined, as you can see, because it has two possible. It's either of type T or undefined. So initially it's undefined. Obviously, changed is false the first time through, and change gets reevaluated each time. That's what happens. So if the last value is not equal to undefined, then we do a deep equals comparison. This is a library called fast deep equals. The fastest deep equals out there right now. It's a lot faster than low dashes. It's a lot faster than a lot of them out there. It's probably one of the fastest, and that's why I use it within the library. Yeah, I mean, it's only like 60 lines of code. If you want to go out, if you want to look for their GitHub, you can actually go through his code. It's pretty basic, but it does its job. It's really good. So basically, that's what we're doing. We're taking the last value and we're taking the current property. Since we don't know, we're using deep equals because we don't know. In our example was a Boolean, but it very well could be an object, and it could be an object with objects inside of that, which objects inside of that, and objects inside of that. You could have multiple nestings of objects. So that's why the deep equals. In our case with the Boolean, it'll be a real simple comparison. Actually, there at the top of fast deep equals, that's one of the first things it does. It tries to find other comparisons that are not objects and does those first. So in our case, fast deep equals will come back extremely fast, and it'll either be, has it changed or has it not changed? So Then we get the value if it's changed. We put that back in there with the previous value, and then we kick it back. So basically, each time that the component renders and we use the use property change, we determine was there a change that happened, and we tell them what the previous change was. If there was a change, even if there wasn't a change, it doesn't matter. At the very end, we go ahead and we set the property back to last value. Now, why do we do this? This is going to be some basic concepts of programming. Why do we always set the property back to the last value .current? Here's why we do it. Because would you rather put another if check in there? It doesn't matter. Assignment is not going to be that complex of a thing. And if you check it and then put it back in there, you're actually doing it twice almost. You're checking to see, especially in complex objects. Imagine doing a second deep equals on a complex object. You've already got one deep equals here. You don't want to do it again. So we always reassign the last value, because it's just a lot easier than trying to do a check and then do the assignment anyways, because then you're doing it twice. You're always doing it. So in this case, you're just always reassigning it. That's the easiest way to go about doing that. Like I said, I told you it was pretty simple. There it is. It's, what is that, 9 to 25? Yeah, it's about 15, 16, if you count about 16 lines of code. So not very complex, and I have a good amount of spacing in here. So if you take out the spacing, you got less than that. So pretty simple, pretty basic. But what this also adds is, for those of you that have worked in other front end frameworks, Angular has something very similar to this called ng-on-changes, and it does something almost like this. It basically does that to where for each potential property in that component on ng-on-changes, when something changes, it'll populate it in there, and it'll tell you the last value. So if it's in the changes object in ng-on-changes, then it will show you the last value as well. So you'll know what has changed. That way you can do certain actions on it. And that's the idea with this as well. I was putting this in here because honestly, that's one of the things I really missed from Angular when I started working in React, is the ability to actually see what the previous value was. So that's why this was created. Let's see here. This one I want to bring up as an example of what I'm talking about when I say what TypeScript can do, and why isn't this doing the nice coloring. This had the coloring. I think it's because of my screen share. Sometimes, I don't know if any of you have ever seen that before, but screen shares can sometimes cause things to not work. This should have a nice little coloring with it. The idea of this one is to replace a property with a different type. Basically, a good reason to use this is maybe if you have an inherited component or you have an inherited interface that has a basic on change and you want to provide it. This is what I used it for, by the way. And you want to provide a more specific on change to it. So then you could override that. There's a lot of reasons you may want to replace one property with another. What this comes down to is, if you look at this has a lot of really nice features of TypeScript. Once again, we're dealing with generics here. And we have key of. So type gets passed in first. I may want to show how this is used. I may want to go back and actually show how this is used. But when you say key of type, what that does is that lists out every potential key in that type. So if you have like the objects I showed before, where you had like 5 or 6 different fields in there, it would actually list them out. When you do that, then you can actually type in the name. As you type in the name, TypeScript will then give you autocomplete. It'll do autocomplete for you, and then you can. Then you can actually see what's, because you may not remember what the property name is. So as you're typing it in, it'll autocomplete for you. You're like, oh, that's it. Or if you don't have autocomplete in your IDE, at least TypeScript will throw an error telling you that's not a valid type. So it won't let it go through when you do stuff like this. That's why key of is such a great thing. So key of type, then show, then this type here basically allows you, it kind of restricts your input to only those keys that are allowed. It's a really great feature there. And then this actually takes whatever you typed into replace key, and this does the actual replacement here of that new type. So it takes the old type and puts the new type in there. So that's really all it's doing. It's very small, but extremely powerful. And this is the kind of stuff that TypeScript really brings to the table. It brings to the table the ability to override things, to change types of things, to make it to where you it helps you as much as possible. It catches the idea, the main point. It catches as many errors as possible in design time before you run it, and before you get these explosions, and before you have to go through and have to dig through these things for hours and hours on end, and find out it was just something stupid that you made. You know, you typed a character wrong or something like that. A lot of times that happens. A lot of times when you don't have proper proper typings and proper things like that, you don't know what the actual property names are. You type it, you think it's right, and then suddenly you start getting this error and you don't know where it's coming from, because you don't make one change and check it, do you? You make a bunch of changes. You change this, you change that, you jump all over the place, you make all these changes, and then you go and you actually test the site. So let's see here. This is something I wanted to bring up. I wanted to bring this one up once again, still using generics. I actually mentioned this yesterday to a person and said I would showcase this. Use deep memo. So once again, using the actually this right here uses the deep equals, just in case anyone's wondering. So it uses deep equals to do a comparison, and this does its own memo. Now, memoization is not something specific to React. Memoization is a concept that's throughout software development. Basically, what in React and in JavaScript, when you have a property that is an object and you pass it into a component that accepts that object, it does not matter that the actual field, the actual values of that object do not change. Your subcomponent will always re-render if you don't memo the object in the parent component. Why is that? Because JavaScript does something called an object.is comparison. Object.is basically is kind of almost an equals comparison is all it is. And in the case of objects, it doesn't compare, it doesn't go into the individual fields and say this field, this field, this field, this field. No. It does a reference comparison. It does a comparison on the object reference. And that's what memo does. Memo saves that reference, and that's what this is doing here. Basically, we kind of set, this is the dependency list right here. This underscore memo is the dependency list to determine if a dependency has changed. That's when we would want to recalculate the memo. So then we determine if is changed is true. So basically, if we don't have any properties, which could mean that we physically don't have any properties, but this also, the first time through, the memo doesn't have any properties yet because they haven't been set yet. They're not set till they're inside of here. So either if the memo, if there are no properties set in the memo, or if one of the dependencies is changed, which is what this is doing here. Arrays are different. Ba-boom. Basically, it's checking the different. Oh, by the way, memos.current, the first one is, as we see here, the dependency list. So the array is the dependency list, and then the actual whatever the object is. It could be a Boolean, by the way. It doesn't have to be an object, but I don't see why you'd use a memo for a Boolean. Usually, if you're using a memo, it's for an object. And so that's what this is. That's why it's memo current 0 here. In case you're wondering, that in and of itself is an array as well. So that is an array of dependencies. Could be one, we don't know, we don't care. So we're checking that versus the passed in dependencies. So that's what we're doing. We're constantly checking if the array is different. When one of the dependencies change, then we go in and we recalculate the memo. If not, if nothing has changed, so after the first call, the second render through, if nothing changes, this gets skipped over and we just return the object over and over and over again. Now that object right here, since it's a ref, returns the exact same object as it was before, and that will cause the object.is comparison to actually say that it's equal. I guess it would be succeed in that case. Yeah, to succeed, to say it's equal. That's what that's what we're trying to get to here. And, I'm sorry to go through that, but I did say I would go through that for someone and kind of showcase this and showcase really things about that, memos, and really where TypeScript comes in, and really TypeScript plays a huge role in a lot of these things. Generics are really probably one of the coolest features. I try to reuse that as much as possible because it allows you to take your code that you write and use it across the board. It allows you to write something more generic and not write something for a specific type. That's where the whole generics come in. That's where the concept comes into play. Let's see here. I did say I would jump back over. How long have we been doing this? Oh wow, we are, yeah. We're we're at 2:45. I will jump back over there real quick because I did say that I would show how that. Let me see here. I did say I would show how replace property is used. So let me do that, and then I think I'm going to end. I don't want to keep everyone too much longer. Pop back over to BSoft components, and I said it's called replace property type. Here, let's take a look for it. Replace property. Here we go. Replace property type. And like I said, it's for the on change. This is the checkbox props. Here's what I'm talking about when I said this. So replace property type, it passes in the headless checkbox props, which has all of, well, you just saw them right there. All of these items right here. And on change is in there. And instead, though, it allows us to change the on change from, in this case, headless checkbox props. The on change was of type, oh, unknown. That's why. Yeah, it's of type unknown. And we gave it an actual type. So basically all we did is we took the unknown type, since we don't know it, and we gave it a real type. So that's all we really did in this case. But that way, when the checkbox fires an on change, it's not firing an unknown, it's firing an actual type back to our user, because we would rather have our user actually get this event type here, which makes more sense to them: name, value, checked, original event. Which, by the way, all of the BSoft components have a basic structure like this, especially the original event part. So basically, we give you the actual event that was triggered by the actual component under the hood. That way, if you don't like the properties that we split out, you can go and you can find all of them yourself. So you can find the property you're actually looking for. That's the idea behind doing that, in case anyone's wondering. But yeah, that's where something like this comes into play. And let me see if it will showcase this in what I'm talking about here. So if I type, do you see how the autocomplete is happening here? See that it wouldn't allow me to type on X because there is no on X. If I typed on X, it would give me an error. So there we go. That's the idea of doing that in TypeScript. The idea of doing that is so that we can make sure that we validate that they are overriding the right property, because we're only going to allow them to override properties that actually exist. That's the idea behind TypeScript. That's the idea behind generics, and that's where it plays this really, in my opinion at least, it plays this really important role in software development, in creating quality JavaScript software, and making sure that you know what types you should be passing in to what functions, to what methods. There's a lot more that TypeScript has. I'm planning on doing a master series, which I'm going to probably name it a TypeScript master series, even though like someone pointed out, TypeScript is kind of like SAS for CSS. But the typing system, I think, plays such a major role in making JavaScript more usable that it really is something really nice to have. It's a nice feature to have. We will go ahead and just stop screen sharing and go back to this. I think it's really worth it in the end. I think TypeScript is really worth it in the end. I think it's great. It's a great thing to use. I know there's those that are the detractors. I just seem to think that the people that are detractors just haven't written those applications that are really, really a nightmare to use. And I did. I had to write those applications, and I want to forget that time because it was just horrible. It was absolutely horrible. Really, it was, because you were chasing bugs, and then the code you had to write. Oh, just remembering it just makes you want to go get it out of there. I don't want to remember. It's nightmarish. But yeah, that's pretty much it. And that's why I think that's why TypeScript. That's why I think TypeScript was invented. That's why I think TypeScript has been so popular. That's why you see so many people use it. Those that are always bemoaning that people are using TypeScript. I just don't think either they really are a glutton for punishment and they just really love doing things the hard way, and they love errors, and they love and maybe they do, and they love errors, and they love spending hours upon hours tracking bugs, which, by the way, like I said, the project I'm working on, that where someone created it without TypeScript, I did that same thing. It takes me an eternity to find anything in there, and I've put TypeScript in it to a point, but still, it's only about maybe a quarter TypeScript right now. And it just, which is nice, because you don't have to implement TypeScript right away. You can actually bring it into a previous JavaScript project. And oh, but if you do that, by the way, here's a real quick tip. If you bring TypeScript into a project that was previously JavaScript, especially a component based system like React, you start from the back and go to the front. You can't start from the top level of your component tree. You got your component tree like this. If you start here, you have to go all the way down. You start from the bottom. You start down here at the very bottom, and you work your way up. That way, you don't have to sit there and replace all the components. You replace this component, that component, that component. You do your dependencies and things like that, and you get it a little bit better. And then the next time around, you kind of go up a little bit higher, and you get a little bit better, and a little bit better, and a little bit better. If you start from the top, you have to do the whole thing. So that's the hint. If you're going to take a project that's already JavaScript and you're going to put TypeScript in it, start from the bottom of the component tree and work your way up. So I have kept people way too long. I hope it was at least interesting, and I hope it was informative. I'm going to go ahead and disconnect. But if you guys have any questions, you can always hit me back up. You can always hit me up on X, on LinkedIn. Subscribe on YouTube, as the little thing down here is showing, and Twitch, for those of you that found us on Twitch. Thanks for the thanks. I hope you learned something, and we will talk to you guys next week. I will. I haven't come up with an idea. If anyone's got an idea for something you want to hear about, hit me up. Hit me up and suggest something that you want to learn about that's within the web space. Web 2 right now, I guess, is what technically they're calling it, in that space, because that's definitely where a lot of my experience currently is. Although I do have experience in a lot of other places. But as I showed, earlier there with all the different languages. But let's see. Hang on there. So you said that TS is a compiler, right? But what does it compile to? It compiles to JavaScript. Exactly. So